Okay, so today's tech talk is about Scala. Scala is the language we've been using in people relevance. We've been pushing it for the last 4 or 5 months to help us develop our models and so forth. We had 3 people prepare this presentation, myself, Rich, and Alex, our intern, who, even though an intern, became quite proficient in Scala in the last few weeks. And we're going to go over why Scala is a good idea, what are the things that excite us in Scala, and give you guys a chance to understand how can you get started on Scala. Okay, so the goal of the talk is, like we said, increase visibility in Scala attack, see some cool stuff that sets it apart from Java, and be inspired to try it out. So we're not saying you guys have to write in Scala or so forth, but we hope that the examples we're going to show you will be cool enough for you guys to feel kind of wanting to play with it. So we're going to go over some cool things about Scala, how we do the same cool things in Java, how to set up the environment, and how to bootstrap your learning process. So the first thing about Scala, it's a functional language, right? It's about transforming and manipulating data. It's also an object-oriented language, right? About organizing a functionality and data with objects. So in Scala, we get the best of both worlds, functional and object-oriented in the same language. It runs on the Java virtual machine, and that means it can call Java code seamlessly. It can import Java libraries. So all the Java code we have attacked, we can call it directly from Scala. It compiles Scala code and Java goes together with the same compilation process, making it very reusable for us, right? Because we can use the code base that we currently have. So let's talk about some things that are cool in Scala that we cannot do in Java. First of all, we can treat functions as arguments. We can pass functions to other functions and so forth. So here we have an example of a component that allows other functions to register as callbacks, right? So all I'm doing is I'm creating a list of functions that accept a click record and return some kind of a unit. A unit is the basic object in Scala. And I create a method called register that expects a function as a parameter, and I add it to my list. So the first thing that we see is that the syntax is fairly simple. I'm just saying a function is something that takes one thing and transforms it to something else. You can also see that when I'm adding items to my list, the syntax is relatively simple. It's like using arithmetics, right? Even though callbacks is not a primitive variable, I can still use arithmetic to add things to it. And now if I want to do the same thing in Java, it would be much, much longer, right? Because I would have to create some kind of an interface called callback that implements a method, and my function register would expect instances of that callback, and that callback would have to implement the method callback and so forth. So it's a lot more, wordy. So in Scala, we can create functions and pass them very easily. Another thing that's really cool in Scala, and people who work with functional languages probably are familiar with it, is type inference. I can define 2 methods, foo and foo2. Foo would return a string called result. Foo2 will return the number 2000. If I have a third method called foo3 that expects a string, if I'm going to pass to it result, it's going to compile. Because the Scala compiler knows that foo returns a string, even though it's not defined anywhere. It's smart enough to look at the return type. If I try to pass foo2 to the method foo3, it's not going to compile, because the method foo2 returns a number. That's the cool thing about Scala, that it can keep your code very type safe at compile time. It can check all the return types of the functions and make sure they all match what is expected. So it kind of combines the type safety of Java with kind of the more flexible coding style that we know from functional programming. Right. So now that we know some of the basics about Scala, we want to talk about collections. One of the strong things we use in Scala for is for manipulating data, transforming data, processing data. So obviously we're going to be working lots of collections. If you have projects that need to manipulate data, if it's user data, if it's algorithm, it can be anything really. Manipulating data files, logs, and so forth. You're probably going to work with collections. Like we saw in the previous example, I can work with collections using simple operators like columns or plus equal and so forth. I don't need to use specific methods, right? It's my code. And it makes the code very easy to understand. If I want to add 0 to this list, I can add it and it will evaluate to be this list. If I want to combine two lists together, I just use the operator of 3 columns. It's going to combine the two lists together. If I want to do operations on list, the syntax is also very, very simple. List for each, and then I pass a function, right? Because Scala is a functional language, I can pass a function to the for each function, and I'm going to tell it for each item, update sum to increment the value of that item. A different way of doing that, for those who are familiar, with MapReduce and collection operations, I can do an operation called a fold right. So I'm going to advance on the list starting at the index 0, and I'm going to take the previous item and the current item and combine them together. And eventually, the result of this folding is going to be the sum of all the numbers. So you can see it's very easy to manipulate lists. Some of the other cool stuff in Scala, I can tell the collection to take items from the list while the items are bigger than 2. And I can tell the list to filter. So I can say list.filter. I can pass a function that takes an item in the list and calculates the modulo. And as long as it's 0, it's going to include it in the filter list. And then I can add another operation in it and say fold right and sum it, and I'm going to get the value of 6. So for those of you who are familiar with Java or PHP, to do these operations usually in other languages would require a lot more work. We'd have to create for loops, we create temporary variables, outside variables, and so forth. But in Scala, we can do all those data operations in one line, right? So for example, in people relevance, we have a component called people ranker, where we have a list, we have arrays that have 20 million users on them, and we're doing various operations. So with Scala, it makes it very easy to do that. Some other cool things we can do with Scala is linear algebra with lists, right? So it also makes it very easy for us to do matrix multiplications or work with vectors and so forth. I can take 2 lists and combine them, and I can get a new one that has the sum of them. I can take a list and divide it by 2, so it will turn to me a new array with the values divided by 2 and so forth. I can filter arrays. I can take a map, for example, like a hash map, and I can multiply it by 2, and that's going to multiply each item in the hash map by 2. So again, Scala makes it for us very easy to manipulate data. If we would do the same thing in Java, we have to create some kind of a for loop, or iterate on all the values in the map and take out each value and multiply it and then put it back in the hash map and so forth. In Scala, we can do those things in one line, making the manipulation very easy. So, the one thing that is different in Scala that we don't have it in Java is the concept of tuples. I'm not sure how to pronounce it. I say tuples, some people say tuples, tuples. So, as a foreigner, that's my excuse that I can pronounce it.
Whichever makes sense.
So a tuple is a unit. It has 2 or more type members. It's different than an array because each item in a tuple can have its own type. For example, string and long. So I can differentiate. And types have to agree by index position with other tuples in a collection. So I can make a list of tuples where each tuple is a string and a long. For example, a list of users: Jane, age 27, John, age 43. And that makes it easy for me to represent, data that I'm working with. The representation is very intuitive. If I wanted to write the same exact thing in Java, it would be much, much longer. Instead of 1 line, I'm going to have to write all of those lines, right? I'm going to have to create a class. I'm going to have to create a constructor to construct the class. I'm going to have to create a list and so forth. Rich?
Yeah, so to be fair, Scala has already provided this pair implementation, and you can get that same pair implementation in a Java library if you just go out and find a good one. But still, if we go back to the previous slide and compare this list initialization and probably the most convenient way of adding an item to the list, rather than making it one big inline thing from an array. These lines right here compare, let's jump back, to just writing it out. These are your values.
So obviously, this is very useful for unit testing. If you want to mock data and so forth. If you look at the unit testing in Scala, they're very concise. They're very clear to understand what's going on, because you don't need to jump through hoops to generate, generate our data. That's cool. Okay. So let's go through some more examples. And again, the takeaway from this presentation is just seeing a collection of cool stuff about Scala. Hopefully, you would find inspiring or related to something that you guys are working with. Data structure manipulations, right? So another very cool thing about Scala is creating collections. The keyword yield means in Scala something different than what it would mean in Java. It means that the for loop itself will not only do some activity or some transformation on the items in the list, but it will actually generate a list as a result of the for loop. So I'm defining the x to be equal to the result of a for loop. Makes it a very easy way to create collections, basically, right? So here I just loop on all the users, and I yield a list of tuples where I is an index, and users would find it creating some kind of an object that represent the user. Now, all the collections in Scala support various operations like filtering, sorting, take while, for each, and so forth. So in one line of code, I can say x equals the result of that for loop, and in the end, sort it by the second item in the tuple, which will be the user, let's say like a username or something like that. Again, if I write it in a different language, I'd have to go to do various iterations. First iteration to create a list of users, then second iteration to sort on it, and so forth. The symbol underscore is it's a unique thing for Scala, and it represents the value of it, and it is basically this for the current item in an iteration. And if you look at Scala code, it might be very confusing in the beginning because you're seeing lots of underscores and columns and various symbols. So if you get confused, just remember that underscore is a very important operator.
It's important to remember that underscore here, underscore 2, is just using underscore as like a Unicode character to start off the name of a member of it, okay, the current item in the iteration. It could have been $, or it could have been the word second in a pair. So it's just, that underscore doesn't mean anything. It's just the character that shows.
Right. So again, a very concise way. If I would write in Java, I would have to create a temporary variable to hold my list and start populating and so forth. It makes the code relatively easy to understand, and helps at least us. It really helped us to translate the ideas we had in our head, or the pseudocode that we had, into actual programming language. Yes, please.
When you're doing a fold,
yes.
you have this and that.
When you're doing a fold, yes, this and the next one.
Yeah.
Or if you fold it from the left, this and the previous one.
So which underscore is this and which underscore is that?
I think when you're doing fold to the right, is by the order they appear, basically. But it's something I would have to check. I don't remember. It's a good question.
And what's the default fold? Is it always fold left and fold right, or is it fold pointed to fold left?
I think it's fold left and fold right. Yeah. So here's another example of manipulating collections in Scala. Let's say I have a list. I have a list of users, and I want to divide it into two parts for some algorithm. I have the keyword of take, and I just say list.take and divided by 2. That will give me half the list. And then I say, you know what? I want to get the other half of the list. So I'm just going to say list.reverse.take and give me the other half of the list. So Scala makes it very easy for us to chain various operations on a list. Here's another example of how I want to convert a map, like a hash map, to a set. I can take part A, which is a list. I can map it in a way that X, which is an item on the list, would map to the result of get user. And then in the very end, I can convert it again to a set, so I have unique members. So the transformation of list to a map to a set is very easy. It just takes one line. And that's because we're using the functional language aspect where I can just pass a function that takes X and returns get user of X as a parameter to map. So if anybody worked with MapReduce, it's very similar. It's just done in the context of the virtual machine. Another example is, let's say I want to get the click history of all the users above age of 18, and I can do that very easily again with one line. Just say set a filter. I give it a method where I return true if the user age is above 18, and over the results of those users, I create a map, and I say for each user, give me a tuple of the user ID and the clicks for that user, and I get a click history. So with one line, I already did a whole bunch of stuff. And when you write algorithms, you want to minimize the amount of lines we have. Otherwise, the code will be very difficult to understand.
If you've been using first-class functions in JavaScript, then the syntax here with the fat arrow, you would be passing a function into this map function in JavaScript. You would be doing function X with your braces for your method body, and then you would have return get user. Okay, so that would be that's the syntax you're seeing here with an argument name, a parameter name, separator for the actual expression body, and then followed by the expression.
Cool.
So that's lambda.
Lambda.
That's lambda, basically. And omega mu.
So if I can cap the list, what half am I getting?
Excuse me?
When I can cap the list, what half am I getting?
The first half. So basically, when I say take, it means it's going to take the first and divide by 2 items in the list.
Oh, okay.
So that's why if I want to take the other half, I want to say reverse the list and take the other half.
And is already implicitly defined for you?
No, for this example,
Oh, okay.
it's like in the cooking shows when they say, I pre-prepared this chicken in the oven. We're pre-assuming that n is the size. The other cool thing about Scala, that all those operators, take, map, reverse, all those things, they apply to all the collections, right? So you can write code that can be oblivious to what collections you're working with. It's a list or a set or a tree or whatever, it doesn't really matter to you because you're just manipulating the data in that collection. So it makes it very transparent.
Yeah, a lot of times take can be lazy too. It's not necessarily lazy depending on what you're taking from. But take might not even fire until you try and use an element from part A. And even then, it may only fire each iteration as you take next from part A.
So basically, if you have some pseudocode in your head to perform some task, some algorithm, it will be very easy for you to translate that pseudocode into Scala. Other cool things in Scala is member variables. Let's say I want to create a class of a user, a bean, whatever you call it, that has an age, ethnicity, and a name. In Scala, I do it with one line. Class user, and I give the variables, and I'm done. If I want to do it in Java, then I gotta define a class, I gotta define the member variables, I gotta define a constructor, and so forth. 10 times more of the lines, right, in Java than in Scala. And it makes it very easy, right, because like writing code, writing less lines, things can move very fast. One other aspect of the concise type, concisity, how would you say?
Concision.
Concision, the concision attribute of Scala, is that it allows us to iterate on our code fast. Because we can write things very concisely, we can take the chance of writing prototypes or writing code that we're not sure if it's going to work or not, or trying new ideas. We can do it very fast because it doesn't take a lot of time to write it. And if it doesn't work, we delete it and write something else. So it definitely supports agile development in a very intrinsic way, as you can see. Yes.
How does Scala deal with equality?
With
Equality.
very similar to Java, you have the equals method.
So you have to define an equals method already.
Yeah.
But in most cases, most types are going to have the equals operator overloaded. So if you call the equals operator on string, it's going to do the equivalent of like a dot equals method.
Yeah.
Because somebody would have come along and added the convenience of overloading that operator.
So, quick question.
Yeah.
I couldn't help notice how confusing slides are sometimes with Java syntax and Scala syntax.
Yeah.
So, some cases where you should be using angle brackets for generics, you can be using square brackets, and sometimes you should be using.
Yeah.
So as you program it, do you find this problem?
It only becomes a problem when we try to program in Java again. It's really easy. And actually, Alex had a hypothesis that things are so easy in Scala, there's no motivation to remember Java anymore. It's just the brain, is kind of naturally lazy for getting that. But yeah, there's some differences. In Scala, you don't have to put semicolons in the end of the line, and generics are square brackets instead of how do you call them? Angle brackets.
So this like betrays one of the pain points of like migrating from Java to Scala or the other direction. Is this obviously was copied and pasted down to this line and then not cleaned up. The types being like postfix on the variable declaration is kind of the biggest inconvenience. The brackets are not really that big a deal. Adding types and final and things like that are not that big a deal. Really, the biggest one is right here, is swapping these types because that's a whole copy and paste operation.
Because you haven't talked about that.
No, so if you're going from Java to Scala at the method interface level, then and you need to be implicit, then that's when it's inconvenient.
If you use a good IDE, then it should catch those errors as you type in, depending on the extension of the file. So you should be safe with that. Another thing that's unique for Scala is the concept of objects. Objects are singletons. There are no static values in Scala. Objects give you a concise way to wrap up constants, and also can be used as factories. So for example, I can define a class of the user, which is something that I can instantiate to create users, and I can define an object of the user, which is a singleton in the system. I can use that object to define some kind of constants, and I can define some factory methods or other kind of methods in that singleton object. So when I use it, basically, I can write a code like that. Current user equals user, which is that object, dot new John, and it's going to create for me a new instance of that class. The cool thing about it is that we don't need to do any kind of singleton or factory management. We don't need to create any kind of static variables to hold it in memory.
So yeah, I mean, this is a global variable, so this is not an endorsement. It's just an example of all of that static state. It's confusing on knowing where to put it as you move code over to Scala, and it goes in object. Same type and image class.
Yeah, so that's definitely a good point. If you migrate from Java to Scala and you're using static variables, they go inside of objects. And as Rich mentioned, they're global in the JVM. So if you're writing a real web app, obviously you don't want to use this kind of singletons because you want to have singletons based on your context of your application and so forth. But again, it makes things very easy to understand, very easy to write, very fast for prototyping purposes, which is very useful. So, now that we went through some of the basic cool stuff about Scala, we have a few of the more complicated things about Scala. And one of them is implicit. And the idea is of being able to extend the Scala language with new functionality and new operators. So I can define actual operators for the language. Some example, I can say that all Scala collections should add the method sJava. If I want to easily convert collections from Scala to Java, one place you want to do that is whenever you use Hessian. Right? If you export the Hessian interface, you probably want to export it using Java objects, because then it will be compatible with other services and applications at tagged. If you export it with Scala objects, the Hessian protocol might not know exactly how to translate the Scala list between the Java list and so forth. I can add, for example, an operator. Let's say I want to add an operator or a factor equal to lists. I can do that. And I can add a mock operator, for example, on singleton. So I can take the language and add new stuff. The advantages are that it is applied across the board to any class or object. I don't need to extend classes or traits. Traits in Scala is an interface. So if in Java I wanted to add some new operator to a class, I would typically extend it and add a new method. In Scala, I don't need to do that because those new additions would apply across the board. And when I add new functionality, new methods or new operators, they don't change or affect the classes or objects that I'm extending, right? So the compiler knows that those methods are being added. So Rich has a few examples with code.
So
how this concept works.
So one really convenient feature is to add an extension method to a class that doesn't really exist on the class for convenience. And it's a way to bring like the functional programming world and the object-oriented world back into like some union. So up here what we have is some housekeeping stuff for adding an extension method to an existing class, and we're going to use a list. So here's the list that we're dealing with. And common like operations on lists and like the ML style functional programming is like head or tail or take while. So so the list class in Scala has head, which means it'll take the first element. All right. But sometimes, like especially in a web programming environment where you are expecting parameters from the web and you maybe didn't get any, your list might be empty, right? And so the output of this print line statement, when we use the head or 0 method call, where we're passing in 0, will, in this case, print out 1, and in this case, where we didn't get anything for list, it'll print out 0. And what's going on here is up at the top, we're saying, let's define some type parameters. We'll call it A. That's in brackets there. And so that makes it generic. That means it's going to work with integers, and it's going to work with strings, and with any other type. All we're going to do is we're going to enforce that if we're using a list of A, that we all also have to return A. And so in the case that head is present, okay, on the implicit it, okay, then we'll return head. And in the case where it's null, or nil, we'll return f, which is our argument, okay? And f has to have its type agree with the type of the list A, okay? So if we try and use 0 right here, we'll be told, you know what, you can't call head or 0 on a list of strings. And so we'll have that type checking at compile time, and we'll have that type safety. And we can eliminate, we can add some convenience to working with classes, and we can have all those benefits of static type checking.
So one of the benefits of this thing, I think, is immediately visible is if we have legacy code or legacy libraries, or let's say we downloaded some kind of an open source platform and so forth, and we're not happy with the methods those classes have, like they're missing functionality, or like we say, I wish they would have some method that they don't have, we can use implicits to extend and add those methods to those platforms or those libraries. If we had some old tagged code that is wrapped up in a Maven factory, and we say, I wish there was a method that would return me the session ID on all those users, or something like that, I could add those methods using implicits without having to go back into the source code of the library that I'm importing or changing it. If I'm using some Apache libraries like Mahout or something else, I'm not happy with it, I don't need to go into the source code of the Apache library and change it. I can just create an implicit, replace or extend the functionality that I want to have.
This implementation of extending the class can live somewhere else. It's actually brought into use here, that first line up the top. Bring in everything on list implicits, make it available here. On the next slide, we'll keep everything the same, but we'll change the implementation. This is goofy. You wouldn't do this, but instead of returning H and F, we'll return a new list with one item in it, or an empty list. So the output is list 1, the empty list, list A, the empty list, right? So we changed what's actually happening here when we call head or on list, just by changing what we import. So with a one-line import change, you can change the behavior of what head or is doing. That's good if you're like fixing a bug, right? You just fix the bug in one place, and then everywhere where you're using it, you will get the correct behavior.
Yeah.
So this pattern in the Scala world is referred to in the sense of pimp my ride. It's referred to as pimp my library, because your library didn't used to have head or, but I saw that you liked head or, so I gave your library a head or, and so that's that. So there was a big contentious argument in the Scala community like last month though, that it was one camp was that it's from Pimp My Ride, and the other it's no, it's misogynistic and legacy. And
Maybe you can use that.
Yeah, but if you want to remember, it's parameter implicit, okay, method pattern, because you're adding this this new method here. So parameter implicit method pattern.
Yeah. And of course, also good for unit testing and for mocking, right? Because you can replace various implementations. Yeah.
What happens if you import both?
I don't see what both, Rich.
I don't know. We can find out by the time the talk's over. We can find out.
We'll find out and we'll get back to you. So one thing about Scala is like we're still working with it, right? Me and Johan have been working about it for like 4 or 5 months and so forth. We're writing production code, but there's still a lot to learn. It doesn't mean that we can't be productive at it. It just means that there's still a lot more potential to use. So, what's next? First of all, let's review. So Scala is concise. We can iterate very fast on our code. It's feasible, so we can translate IDs into code. It's very good when you're trying to write some new project or you have some new idea you want to develop and so forth. It's very versatile for writing unit tests. It can also power web apps just as Java does. So it's not necessarily just for algorithms or models. Anything that you can write in Java, you can also write in Scala. You can use the same libraries. You can even use the same patterns if you want. And you can make it better, by migrating your patterns. But generally, you can write Scala the same way as you write Java. And you can take a look at some current typed projects using Scala. If you go to GitHub, there's the people relevance repository there, and you can take a look and see what happens. So, let's say that you found those examples interesting and you want to play with it, you get some time. What do? Setting up the environment is very easy. You just need to add 2 lines to your Maven. You gotta add the Scala plugin that will help compile Scala code, and you add the Scala lang dependency to give you the Scala language. We tried using various development environments for developing Scala. We tried Eclipse, we tried Vim editors and so forth. We found IntelliJ to be the most useful. It has really good intrinsic support for Scala. It offers you code completion and in-editor syntax and type checking. Since Scala has all that thing about inferred type safety and so forth, the editor has to be pretty smart on figuring it out, and IntelliJ does it really well. So if you want to get started fast on Scala, I recommend using IntelliJ.
So I'm using Eclipse, and it's a little less reliable. But if you need any help setting it up, let me know. But you can go to scalaide.org. Go to the nightly page, get one of the nightly builds. That's my only advice.
How do we bootstrap the learning process? We showed you all these examples. I'm sure it feels a little overwhelming, and you guys looking at it and you're seeing all those underscores, brackets, curly brackets, various letters and so forth. It might look overwhelming, but actually it's very easy to get started with Scala. You set up your environment. The way that we went about learning it, we just chose a simple task. do a unit test, process some user data, operate on some data files, something that's very simple. And just try to write it the same way that you would write it in Java, and compile it, make sure it runs, and then slowly start migrating your patterns to the way, to the better ways or more versatile ways that Scala offers. But again, if you start writing Scala the same way that you write Java, it should work for you, and it can be a very good path on starting to learn it. Another very good candidate for learning Scala is to write some kind of a prototype. Since you can iterate pretty fast, you can write various prototypes or web apps with it. Other things you can do to bootstrap your learning process, you can write some Scala components and incorporate them into your existing Java code. Since Scala compiles into JV and bytecode, you can create a jar made out of Scala code and just import it into your Java project, and it should work fine. Scala is useful when performance matters. It's useful when you want to leverage existing Java libraries. Using a whole bunch of Java libraries for native I/O, native memory allocation, and it works fine. And the features like type inference, pattern matching, and options and so forth, they help you find bugs relatively easily. Rich, if you had something.
Yeah, just I think we cut options, but
Yeah.
just in the pattern matching world where you saw where we were pattern matching on if there was a list and it did have head or if it was nil. There's a whole host of classes that help you decide what to do when you know you may not get something back. And that fits nicely with the pattern matching world and just helps you put a little rigor in things that you might just skip over on expecting certain inputs.
Yeah. So, some of the current things that happen right now in Time Using Scala and the New People Ranker project that we worked on people relevance, and now it's being led by Carl. We have a datagram logger that is written in Scala that logs datagrams that are related to MeetMe. And we build and train all our models in Scala as well. So as I said, all of that stuff is available on GitHub. On GitHub, you can go in, take a look, see what's out there. So, just try and create some kind of a new web service for your next project, whatever it may be. Siteops, I'm sure, will help you deploy your Scala web service, the same exact process as setting up a Java web service.
You can call that service right from PHP. So you have something that just, standalone.
Yeah. So, to summarize, the big takeaway of Scala, it has lots of cool stuff. It's very useful for iterating fast, for manipulating data, for transforming data, and so forth. It's quite similar to Java. So, your learning curve shouldn't, at least starting to learn it shouldn't be that difficult.